Welcome to This Explainer. Whether you're building a massive open world adventure or just a really simple mobile calculator, the fundamental ingredients of software development actually remain exactly the same. Today, we're going to demystify those core building blocks by thinking exactly like a video game creator. Here's our roadmap for today. We'll be hitting algorithms, variables and constants, different types of data, naming rules for identifiers, and finally, operators and math rules. Let's jump right in. Part 1. Algorithms, the master plan. So every single piece of software starts with this overarching concept. Before you even think about writing a line of code, the computer needs a defined set of steps, an algorithm, to actually accomplish a task. Because look, computers are unbelievably powerful, right? But they literally have zero human intuition. They're sitting there waiting for us to give them the exact roadmap. Think of it like the algorithm you use every single day to make a cup of tea. Step 1, fill the kettle. Step 2, place a tea bag in the cup. Step 3, pour the boiling water. I mean, it seems super obvious to us, but computers need that exact same level of microscopic, step-by-step instruction. Your algorithm really has to account for every single tiny action. Moving on to Part 2, variables and constants. Okay, so now that we've got our master plan, where do we actually store all our ingredients? Look at this game interface. You've got your character, a score sitting at 216, and 3 lives. Now, these memory containers dynamically change as you play, succeeding or, failing. And that's the literal definition of a variable. It's a chunk of memory that varies while the program is running. But here's the contrast. While variables are constantly shifting around, constants are entirely different beasts. A constant locks a value firmly in place so it can never be accidentally erased or tweaked by some random mistake in your code. It's kind of like the force of gravity in your game environment. You set it once, and it stays exactly the same for the entire execution. Next up, Part 3, different types of data. So how exactly do we categorize all these different ingredients we're storing? Well, computers have to know exactly what kind of atomic data they're dealing with. For example, you'd use an integer, just a whole number, for a high score, but you'd use a real data type for a fractional number, say a character's weight of 56.8. Then you've got strings for text, like a player's name, or a simple true or false Boolean, which is absolutely perfect for checking stuff like, hey, is the game over? All right, Part 4, naming rules for identifiers. Once we've got all our data sorted out, we absolutely have to label it correctly, and there are strict rules here. You should be using PascalCase, which means each word starts with a capital letter. Identifiers must start with a letter, too. Never use spaces or accented characters. And here's a really crucial quirk to remember. They're considered case-insensitive. So a variable named countdown with a capital C is processed exactly the same as countdown with a lowercase c. But beyond just rigidly following the rules, you've got to be strategic. It's an incredibly good practice to use meaningful names. Sticking to identifiers like total marks or hourly rate makes your code readable, not just for the machine, but for your future self and literally any other developer who might work on your project later on. And finally, Part 5, operators and math rules. So we've got our ingredients safely stored and perfectly labeled. How do we actually mix them together? Well, alongside your standard arithmetic operators, computers use some very specific built-in functions. You've got div, which does integer division. It completely discards the fractional part to give you a clean quotient. And then there's mod, which performs the division but only spits out the remainder. Let's actually see that in action. Say we take the mod of 20 and 3. Now, 20 divided by 3 is 6, with a remainder of 2, right? So the mod function gives us exactly 2. Isolating that specific remainder is honestly just a super powerful trick for programming repeating logic and game cycles. Finally, how does the computer actually read these complex equations? I'm sure you've heard of BODMAS or PEMDAS. But what happens when you have both multiplication and division right next to each other? Well, because computers strictly read operators of the same precedence from left to right, an equation like 6 divided by 2 times 3 is always processed sequentially to equal 9. It never guesses, it follows strict logic every single time. Which kind of leaves us to wonder, what other strict hidden mathematical rules are quietly running the digital world around us every single day? Think about that the next time you boot up your favorite game.